Okay. So 51 is actually, it was supposed to be a partial pressures question, but it was a little bit more than I wanted. So we're going to actually just go to 52. The stoppered tubes below, labeled A through D, contains a different gas. When the tubes are unstoppered at the same time, under the same conditions of temperature and pressure, from which tube will the gas diffuse at the fastest rate? So the lightest gas is going to diffuse the fastest. So when I mean lightest, I mean go to periodic table, which I am grabbing. You don't need me to scroll there. So helium has a mass of 4. Neon has a mass of 20. Argon has a mass of 40. Krypton has a mass of 84. So the fastest rate is going to be the lightest, which is going to be choice A. The heating curve below represents a sample of a substance starting as a solid. So that means this is liquid, this is gas, solid to liquid, liquid to gas. That's very hard to read. This is melting here. Oh, what is that? Oh, I just want this. Solid. Liquid. Which statement it describes what's happening during DE? So DE is a phase change. Notice the temperature remains the same. So that means average kinetic energy will remain the same. So now we're down to C and D. However, the graph continues. So potential energy will increase as kinetic energy stays the same. Which sample of matter sublimes at room temperature and standard pressure? So sublimation is going to be solid straight to the gas. And unfortunately, this is just a memorization one. This is dry ice. Solid carbon dioxide. Which sample represents an intermolecular force in a sample of water? So intermolecular forces are not bonding, even though it's called bonding. Covalent, ionic, and metallic. So hydrogen bonding is an intermolecular force. Hydrogen bonding is fun, which is hydrogen with something very polar. And you look for the electronegativity differences to be very large. So based on table H, what is the vapor pressure of CH3COOH at 90? So let's go to table H. So CH3COOH is not listed here, but if I go to ethanoic acid, that's what CH3COOH. And I believe it's set at 90 degrees. So 90 degrees, 80, 85, 90. So, and then that is 1, 2, 3, 4. So this is 40 kilopascals when you... Oh boy, bring it over here. And that is a choice. In which system do molecule-ion attractions exist? So you need aqueous. So how that works is that K would be C plus and Cl minus, and then the molecule would be H2O. So it's got to be aqueous. Which statement describes the energy changes that occur as bonds are broken and formed during a chemical reaction? 2 ways we can remember this. One is BARF, broken, absorbed, released, formed. Or you could say this is like your teddy bear, your stuffed animal. Oh boy. When you have your stuffed animal, you breathe a sigh of relief. So forming a bond releases energy. So forming a bond is a release. So it can't be that one. So it could be B or C. And when you break this bond, you're going to put up a fight. Breaking is absorbed. So energy is absorbed, bonds are broken, release and bonds are formed. Which diatomic molecule is formed when the 2 atoms share 6 electrons? So 1, 2 is a bond, 3, 4 is a bond, 5, 6. This is a triple bond, so hopefully you remember that's nitrogen. What is most likely the electronegativity value for a metallic element? So remember that electronegativity means greediness for electrons. So electrons are not what metals want. Metals want to give them away. So we want the lowest number possible, which is, part A. What is least polar? So this is electronegativity difference. So I am not going to turn to table S on the screen. I'm just going to go to table S on my actual reference table. I'm going to see that chlorine is 3.2 for all of these. Arsenic is 2.2. So the difference is 1. Phosphorus is 2.2. So it's difference of 1. Bismuth. Where even is bismuth? I'll get to that. Nitrogen. 3.0. 0.2. I mean, I'm guessing that that's the answer, but I can't find it. Bismuth is way the heck down there. Oh, here we go. 1.9. Yeah, so that's 0.3. So choice D. 62, a nonpolar molecule. Nonpolar molecules will be symmetrical. So that gets rid of C and D. But it contains polar covalent bonds. Polar bonds are the greater electronegativity. Well, even without doing any math, I know that A is going to have nonpolar bond, because who's pulling harder for electrons, H or H? Trick question. So part B. 63, which statement describes the charge distribution and polarity of a CH4 molecule? The charge distribution is symmetrical and the molecule is nonpolar. Well, the molecule is definitely symmetrical. So it is nonpolar. Choice A. Polar molecule, asymmetrical. H2 would look like this. CO2 looks like this. H2O looks like this. And CCl4 looks like that, just with Cl's where the H's are, which means B is our answer. Which electron dot diagram represents the nitrogen atom in the ground state? So nitrogen, if you go to periodic table, has 5 valence electrons. So you would have 1, 2, 3, 4, 5, which is choice C. What is the name of this compound? Okay, so we need to find the longest continuous parent chain. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so right here. Let me get rid of all those other dots. So our longest continuous chain is right here. Meth, eth, prop, but, pent. Now, if you didn't know that, here we have the reference table. 5 carbons is pent. And then I noticed that all of the bonds were single bonds, so it's got to be an alkane, all single bonds. So it's a pentane. So then let's figure out, we've got this here and we've got this here. So this is a methyl, and so is this. So if we have 2 methyls, it's called a dimethyl. And then finally, location, 1, 2, 3, 4, 5, off the second and the third. So choice C. Hydrocarbon would not have oxygen or Cl, just hydrogens and carbons. 68, which formula, hold on one second. Which formula represents a saturated organic compound? Saturated is, oh my gosh, single bonds, which is an alkane. So an alkane, coming back here, CnH2n plus 2. So CnH2n plus 2. So who's got double the carbons plus 2? That would be D. Which formula represents 2-butene? So meth, eth, prop, but is 4 carbons. That doesn't eliminate anything. Ene means a double bond, and it has to be after the second carbon. So let's say this is after the first carbon. Ooh, this is after the second carbon. Ooh, this is a triple bond, and that's a triple bond. So it has to be choice B. Unsaturated hydrocarbon would be an alkyne or an alkene. So it's either CnH2n or CnH2n minus 2. So in the first one, part A, that's double the hydrogens. That's double the carbons. That's right. I could go through the rest, but why? An alkyne is a triple bond. There is at least one, B. I had to look for a second. Benzene, unfortunately, this is just memorization. It is an 6 C's with alternating double bonds. And then, of course, we'd have hydrogens like this. But to simplify it, we just draw the hexagon with alternating. Cracking hydrocarbon molecules. Okay, so when we crack them, we make smaller molecules, and the smaller molecules have lower boiling points. And the whole point of that is that we can use it for different functions, like gasoline. Petroleum is a mixture of hydrocarbons. Petroleum can be separated into different fractions by the process of fractional distillations because they have different boiling points. Alcohol and an ether have the same molecular formula, C2H6O. These two compounds have talked to me about functional groups and properties. So alcohol and ether, if you go back here, alcohol is here, ether is here. Those are two different classes of compounds for organic functional groups. So they are different functional groups, and different functional groups would have different properties because they're put together. So they would be choice D. Two isomers of butane. Isomers are the same number and kind of atoms, but different arrangement. So they have the same molecular formulas, but different structural formulas. Okay, what is an isomer of this? So what I do is I say we have C3, we have H, 6, 8, and then an O. So then part A is C3H, 1, 2, 3, 4, 5, 6, 7, 8. I think it's A right off the bat because part B, it's got 2 oxygens. Part C doesn't have enough hydrogens, and part D doesn't have enough, let's see, 1, 2, 3, 4, 5, 6, doesn't have enough hydrogens. So it's part A. Based on table R, which is an organic acid? So going back to table R, organic acid has C double bonded O to an OH group. So C double bonded O to an OH. And admittedly, these are really close together. I do see that. So part C. Which is an alcohol and an acid. So again, I'm not going to keep flipping back and forth to reference table R. I recommend that you have that so you can hear me flipping in real life. So part A has a C double bonded O to an H at the end. So this is called an aldehyde. B has a C double bonded O to an OH. So we already saw this today, and that's called an acid. C double bonded O somewhere in the center, this is called a ketone. And an OH group somewhere is called an alcohol. So we want an alcohol and an acid, so D and B. What is the name of this compound? Methethprop. And C double bonded O to the end is called an aldehyde. So it's called propanal. What is this? Methethprobutpent hex. And so that's parent chain. But is it an ester, old granny ester? Old granny ester looks like this. And we don't have that. So it's not going to be those. So is it 3-hexanone or 4-hexanone? 1, 2, 3, 4. Looks right, but if you go this way, 1, 2, 3, you go with the shortest numbering scheme possible. What does the IUPAC say? Okay, so we've got methethprop, so it's not but. And then we've got 2 chloros. So on table R, you've got a Cl that's a halide functional group. So we've got 2 chloros. It's going to be dichloropropane. But is it 1, 2, or is it 2, 3? Well, it would be 1, 2, 3 if I go that way, but it'd be 1, 2 if I go from right to left. So we have to go to the lowest. So it would be choice C. What is it? So here's Old Granny Esther right here. So how to name Old Granny Esther. Take a look on table R. In table R, you see that the single bonded O side comes first, so that's methyl. And then you name the other side methyl butanoate. The example on table R is very helpful. An atom of which element is bonded to the carbon atom in the amide functional group. So just for, I guess since we're talking here, amide. Is it amine or amide? It said amide. Whoops, sorry. So who's bonded to the carbon in an amide functional group? That's an oxygen. Yeah, and this is not a choice. Let's see. I guess it's also nitrogen. I would have said oxygen, though. See, that's why I wasn't going to get 100. All right, so what is this? So we have the C double bonded O to this. This is an amide again. Whereas an ether would have an R, whoops, in between double bonded, single bonded O's. So it's going to be choice C. Addition reaction is when you'd have one product. This has two products. B has one product. Two. Addition, there are also alkenes and alkynes. What's going on here? So it looks like we've got a hydrocarbon and bromine, and then one of the bromines went in and one of the hydrogens came out. That's called a substitution reaction. All right, the key with this one, I see dot, 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 I see dot, 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 and I see we're adding. So this is a polymerization. A reaction between alcohol and organic acid. So formation of what? If you've got alcohol and organic acid, that's how you form Old Granny Esther. She's lived a hard life, drinking alcohol, doing organic acid. Fermentation is the production of an alcohol and CO2. So look for OHs. So here's an OH. B is not OH, and I don't see OH in D. So the difference between A and C is I don't see any CO2 as a product in A. And also, this is just an addition. A is an addition. So you need a sugar to break down and form your alcohol. What types of organic reaction forms carbon dioxide and water? That's called a combustion reaction, complete combustion. Organic reaction that produces soap, look for the word soap, just a word jumble. A can was filled with crushed ice, sealed and masked. The ice was melted slowly by warming the can and its contents. No water vapor escaped, no air entered. If the can is masked again after the ice is melted, what's the best prediction of the mass? So everything is closed, which means you should not have any changes to the mass. This is called the law of conservation of mass. All right, if you have any questions, please see me in class. Thanks.